15. Thank you. 15 and 17. I can't write on here.
No, not 17. 17 is so easy.
Okay.
When there's a big parenthesis around the parentheses inside, do you do the inside first or the outside?
Say again?
Like,
actually, you know what I can do?
let me draw something like this. I can't explain, but like I can explain. So when it looks like this and there's parentheses on this side with those things, so I do the whole inside first or do I do the outside to the inside?
I always work inside first.
Inside and then do the negative.
That's what I do.
And then when it goes like, and then when it's like, when you have like a fraction, what do you do with a fraction? Do I put 2 on the bottom? Because when you have a negative, you said that like.
Let me show you. Let me do one like that. Let me show you what to do. All right. Well, you said 7.
That's like
9. 9. Where's the other page?
yeah, 9's kind of like the one.
Wasn't there a back to this?
Yeah, but I just want like a negative. Yeah, that one's negative.
Okay. All right, number 9. Where'd my pen go? Coach Mike, bro. Where's my pen? No. I don't like this whole embedded thing. I'm going to work inside the parentheses first. That's generally what I do. I think it's easier to do it that way. But whatever you want, I will caution you, look outside first, because if that's a 0 like it is on one of them, then your whole thing just goes to 1, right? I'm going to take this to everybody here. So I get 2 to the negative 4, q to the positive 8, r to the 0, I'm just leaving that one off. 2 p negative 1 q3 all over 2qr. Everybody's got this too. I'm going to keep working inside until I get it completely simplified, and then I'll take that 2 to it. If you took the 2 to it first, that's okay also. All right, so I've got 2 negative 4. Q8 and Q3 gives me Q11. Actually, y'all see what I missed here? Up top, I'm just looking up top first. I tend to do that. That's actually 2 to the negative 3 because that's got an implied 1. Q11, and then I've got P negative 1 over 2QR. Still got that 2 outside, right? Now I'm going to do this is just how I go about it. I do all the way across the top, all the way across the bottom, I simplify, and then I put them together. But if you do it a different way, if you move everything first, that's okay. Remember, these can get confusing because there's not a right way to do them and a wrong way. As long as you do genuine properties each time, it's okay. All right. I go through and do this. I'm going to move that 2 down to the bottom. So if there was already 1, and now I'm putting 3 of them down here, that gives me 4 of them down here. 11 up top and 1 in the bottom leaves me how many where? 10 where? Top of the bottom, up. Negative 1, that's going to come down. And then I've got just an R. Everybody okay there? Now I'm going to take that 2 to everything. And when I say everything, I mean everything. So it's going to be Q20, 2 to the 8, P squared r squared. You can leave it like that if you want to, or you can, it doesn't matter. What else? $15? Not on this page, is it? Where did the other page go?
Oh wait, it's
How do you flip it? Ah, nope. Oh, there it goes. Yeah, it did. Yeah, it did. Okay, that's a lot. 15? All right. I'm going to get rid of the zeros first. That's the first thing I'm going to do. So now I think what I will do is go straight across the top. So I've got two 2's, both of them with an exponent of 1, so I'm going to do 2 to the second. 2, that's right. 4 plus negative 4. Take it out because that goes to 0, right? I've got an A3. I'm going to just go in alphabetical order here. And I'm going to mark them out as I use them. C2, C negative 3 would be C negative 1. Ellie, you're getting this. You're rocking it out. All right, on the bottom, I've got a 2, A, C, negative 4. And on the outside, I've got a negative 4. Let me show you a little trick here. You've got every single thing to the negative exponent like this. This is a handy trick, so pay attention. What I can do is just flip the whole fraction to AC negative 4. Keep everything exactly the same, but just flip it over and make that positive. Well, 1b was 4 and 1 was negative 4, so it just goes away. Little trick. Well, tricky trick. Not now. That's the only thing it does is flip. Now, you could have, at this point, I could take this negative and I could take it through to every single thing, and I could go that way. Again, there's multiple ways you could do it. That's just a little trick if you don't like dealing with the negative exponents, and it's to the whole fraction. I'm still got some stuff I can do inside here before I worry about that 4 on the outside. So let's see. I've got 1, 2 up top. I've got 2 2's in the bottom. How many 2's does that leave me where? 3. I got 1 up top, 2 in the bottom. 1 at the bottom. Right? I've got 1A up top, 3 A's in the bottom. How many does that leave me where? 2 in the bottom. Or 1 minus 3 is negative 2 up top, and it jumps down to the bottom. And these two are really just going to swap places, right? Because this would be C1 over C4, which would leave me 3 C's in the bottom. What happens if everything's gone from the top of the fraction? You put a 1 to hold the place. That's exactly right. And I still have this 4 outside. Well, okay, so look at it like this. What's negative 4 minus negative 1? And it's in the top. When you subtract, it always stays in the top, and then you flip it down. You can. No, what I did here was I just took the negative off and flipped the whole fraction. Literally, the whole thing. Kept everything the same, just flipped it and made it positive. Because that's what negative exponents do. They flip. Say that again. Because the base is the same. When the base is the same, you leave that base alone and you add the exponent. Same thing as 4, but we're just doing it. We're working on some properties of exponents here. All right, I'm still not done. 1 to the 4th is what? 1 over 2 to the 4th, a to the 8th, c to the 12th. Yes, ma'am. You could. You could. Anything else? 19. Erase all this. Let's see. I know I got a 0 there. So up top I have 2 to the 3rd, x to the 3rd, y to the 3rd, over. That 0 is gone. I wasn't marking that out. 2 2's on the bottom give me 2 squared. I've got 1x, and I'm just putting them in alphabetical order. It's not necessary. It just helps me keep everything together. Y4, and then I've got a z4 and a z1, which would give me z5. Yeah. Yes? 3 2's up top, 2 2's in the bottom. Leave me how many 2's where? 1 2 in the top. 3 2's up top, 1 in the bottom. Leaves me how many where? 2 up top. 3 top, 4 bottom. Leave me how many where? 1 on the bottom. And then this one just stays on the bottom by itself. And you just put 1. No, that's just a mark on the paper. Sorry. Everybody good? All right, let's switch gears. Why? Because you're worried about it not being right? Yeah, it's just... No, no homework. You just have to have them right, don't you? Classwork, I'll spot check some. Sorry. I'll usually look at just a blank one and I'll say, okay, which are the easiest ones for me to grade? Like I can grade all the ones in this column, or I can grade like boop, boop, boop. Something that makes it easy for me to spot check and grade is why I choose what I choose. It's never any, there's not really a rhyme or a reason other than that. Well, so normally, so like if there's 10 points, if there's 10 questions, I'll make it a 10-point classwork assignment, and I'll probably spot check like 2 or 3. So if I spot check 3, you'll get 7 points for the other 7 just for trying, and then the 3 other points come in from right or wrong. That's how I do classwork. So it's still mostly effort. Even if you try everything, you'll still pass. It's just... All right, here we go, polynomials. What's a polynomial? A nomial that has, this can mean many, right? We know what poly means, right? So many, you're close, not numbers, but terms. And in fact, one or more term makes up a polynomial. And so when they have a certain number of terms, sometimes we give them certain names. Okay, so I'm going to give you a little chart, and we call them certain things. You should have heard these terms before, I hope, anyway. We'll see. First of all, what's a term? I'm saying term like you know what a term is. What's a term when I'm talking about a polynomial? What does it consist of? Numbers and or variables that come together, right? If I'm talking about, give me an example of a term. 2x, give me another example. Anybody else? But that doesn't have a variable. It's still a term. It's still a term, okay? All these terms, numbers and variables added or subtracted, give you a polynomial, okay? We've talked about certain types of polynomials in great detail already. What was that type? Okay, I probably said that wrong. Trinomials, yeah, trinomials. So, huh? Yes, I'm fixing to do that. I was still thinking about the quadratic thing because we're gonna classify them two ways, and quadratic is one of the ways we're gonna classify in the number of terms. So the two ways we're gonna classify, we're gonna start by number of terms. And Gracie, you're exactly right. One term is called a monomial. What do you think two terms are called? Now this is kind of one of those things where a square is a rectangle, but a rectangle is not a square. All of these are types of polynomials. So every monomial is a polynomial, but every polynomial is not a monomial. Right? Does that make sense? Because by definition, polynomial is one or more, but monomial has to just be one. So every monomial is a type of polynomial. How about three? Trinomial. Past three, we just call it a polynomial. 4 plus, yeah. Anything 4 and beyond, we just call polynomial. Now we also classify them by their degree. It absolutely is, and we're going to talk about that. What is the degree of a polynomial? Do you guys remember that? Which exponent? They could have more than one exponent. If the highest exponent. So looking at the highest exponent in your polynomial, we can also classify there, and these we go a little bit further. If the highest exponent in your polynomial is a 0, now what would that look like? Look like what? The number 1, right? What do we call that? What kind of a line is that? Oh gosh. It is linear, but it's just, what kind of a line? What am I trying to say? Hold on. When we're talking about the highest exponent, we're talking about the highest exponent on x itself. So I could have 5x to the 0. I could have 2x to the 0. So yeah, it could be y equals 1, but it could also be y equals 5. Okay, does that make sense? What is x to the 0? 1 times 1 is, right? So all of these have a degree of 0. Hi. 0. It is a constant. That's what I was trying to get you to, but I'm going to just tell you. I always like for you if I can get you there, get you to figure it out, but that's okay. All right, so it just looks like y equals a number. That's what a polynomial of degree 0 looks like. Okay, and that's why we call it a constant, because a constant doesn't have a variable hooked to it. It's always the same. It's constant. If it has a degree of 1, so the biggest exponent on x is 1. What type of graph am I looking at? Y'all can do this. Let's think of an example that might help you. Y equals, give me an example of a polynomial with degree of 1. Biggest exponent on x is 1. 4x, I could leave it at 4x. Or I could say y equals 1/2 x plus 3. Do we all agree those all have degrees of 1? What type of polynomial is that? Other than, is what? Not by the number of terms, it's linear. You're exactly right. It's linear. Those are all lines. It'll never be anything other than a line. Because if it's got a degree of 1, then it has one x in there, and it could or it may or may not have a constant. So for this one, this is a linear monomial because we can classify it both ways by both the number of terms as well as the biggest exponent. This one would be what? A linear binomial. Have y'all ever seen this stuff before? Okay, I was going to say you should have seen all this before. Okay. Wrapping up here. Okay. How about quadratic? You should know this one. This is an easy one. Quadratic. I could have a quadratic monomial, a quadratic binomial, or a quadratic trinomial, because it could have 3 pieces, right? Or is everybody okay? How about a degree of 3? This should be new now. You know what that's called? You're right, keep going. Cubic. This is called a cubic. You were going to say it. I told you were right. Keep saying it. Cubic. 4 absolutely is. 4 is what we call a quartic. What about 5? Does anybody know what 5 is called? Quintic. That's exactly right. That's not a T, that's a plus. Beyond 6, we don't really give them specific names. What's an R? Yes. Like a quarter? Past 5, we just call it a whatever degree polynomial. So if it has a degree of 10, we would just say it's a 10th degree polynomial. Yeah. We'll talk, starting Monday, we'll start talking about analysis of these polynomials, and we'll start talking about what this looks like graphically and what each one. So I wanted you to go ahead and have some terminology here for whenever we get to that. All right, now, Gracie mentioned a minute ago about writing them in a certain order, right? We call that, y'all got that? We call that standard form. And standard form is when we write in order of the exponents, okay? So we start with the highest exponent down to the lowest, which would be the constant if we have it. Might not have a constant, though. You're not required to have a constant. This is just like whenever we were in standard form of a quadratic and it was ax squared plus bx plus c. This is we start with the biggest exponent and we work our way down. Everybody okay with that? What's supposed to be the order? Thanks, guys. Let me give you an example with all this pulled together. I need to go back. Write the polynomial in standard form and then classify it by its number of terms and its degree. Don't blurt out the answer when you get it. Write it in standard form and then classify it by its number of terms and its degree. No. Classify, tell me the name of it based on its term and its number of terms and its degree. Those two charts. Put it in standard form and then classify it by its, no, unfortunately it's not. You're spelling wrong.
I'm a phonetic speller. I'm going to spell it the way it sounds, not the way it is.
But I'll know what you mean.
I'll put a little number in it.
Standard form. Highest exponent down to the smallest, yes? Now let's classify it. What's the degree? It's quintic because it's a 5, right? So it's a quintic. Now how many terms does it have? 3. So it's a quintic trinomial. That's all. Yep. All right. Crank it up. Lane says bring it on.
All right, let's go.
Yes. Today we are going to add and subtract and multiply. We won't get into division until next. Actually, we'll divide, but just by a monomial. So now, well, I had to tell you what these polynomials were before we could do things with them. I will not spend a long time on adding and subtracting polynomials because they are very, very easy, unless you need me to. That is what you are doing. So in order to understand combining like terms, let me make sure that you understand what like terms are. I'm going to move y'all further apart. What are y'all doing? What does it mean to be a like term? Okay, same variable or base and same what? Exponent or power. Now I know you think you know how to do this, but as we move from multiplying to dividing to adding and subtracting, things start getting jumbled together. So that's why I want to take just a little bit of time. How do I combine like terms? In other words, if I had something like, well, you give me 2 examples. Miles, give me a random term, any term in the whole wide world. Huh? Okay, give me a term with a variable on it. 12x squared. Okay, perfect. Ella, give me a like term to that. Give me a term that is a like term with 12x squared. So same base, same exponent. 3 what? All right, does everybody agree those are like terms? What makes them like terms? The x squared makes them like terms. How do you combine like terms if I said add these together? You just you combine the coefficients and you leave the variable that's important. No, if you know it, you definitely don't. So this would be 15, and then I leave that x squared. And I say all this because what would happen if I changed that to multiply? The exponents would then add together, and I'd multiply the coefficients. We'll talk about that whenever we get to multiply in just a second, but it starts to get all confuzzled in here whenever we start. Yes. All right. So all I'm going to do when I add or subtract is combine like terms. Be very careful if you're subtracting. I want to do one subtracting example before I move on to multiply and divide. Let's say I have y plus 4y squared minus 3 minus 1 plus 2y squared minus 5y minus y cubed. This makes my skin crawl because, first of all, neither one of those are in standard form, right? I find it much easier to work with things if they are in standard form initially, but they definitely don't have to be. But because I am very OCD about those kind of things, I always come here and rewrite each one in standard form. It will make your life easier as you seek out to combine these like terms. Again, not necessary, but it's helpful. All right, all I got to do is combine like terms, but I've got a big fat minus in the middle. And what that means is I'm subtracting everything in that second set of parentheses. I'm not just subtracting this first one. I got to subtract this one and this one and this one and this one. Everything in the parentheses that follows the minus sign has to get subtracted. Yeah. You could just multiply by -1 and do a same change everything kind of situation. Okay? That confuses you? If that confuses you, don't do that. Do whatever helps you. If you look at it and you know to subtract, then that's okay too. I will usually come in and do this. That helps me see what to combine, which is essentially just multiplying -1 through to everything. Because it's always easier for me to add than to subtract, right? Really, subtracting is just adding, but whatever. Anyway, now, yes. So all I did, you know how whenever you first learned subtraction, your teacher probably said same, change, change. Same, change, change, everything in the parentheses that follows. But really you do that because you're multiplying through by -1. Now combine your like terms. Start with your biggest exponent from either parentheses so that we do that first. So we're in standard form when we're finished so we don't have to do that in the end. So what's your biggest exponent? Y3, there's only one of those, right? Here's how I go through these, and if you don't need to do this, you certainly don't have to. I will circle the like terms, Y3, I add them, and then I scratch them out so I know I'm done with them. Now I go to the powers of 2. I have 4y squared and -2y squared, which would give me what? +2y squared. Yes? Then I scratch those out because I'm done with them. Again, you do not have to do your work like this. This just helps me keep up with it, especially when my polynomials get like this. I've got a power of 3, a power of 2. How about ones? I've got y and 5y. 6y. I'm done with that one. I moved it around. I did a same change everything. Do you? Now my constants, I have a -3 and I have a -1. Negative. That was easy. All right, on to the good stuff. You actually know how to do it. You just don't know that you know how to do it. We're going to multiply. Multiply is nothing more than distributing, but sometimes we're distributing on crack. Like this thing goes, Never multiply more than 2 polynomials together at a time. That's your trick to these, okay? When I multiply, now you might have learned FOIL, but I hate FOIL because FOIL only works when you've got a binomial times a binomial. What happens if you need to multiply a binomial times a trinomial? You just still got to distribute the same way. That's all foiling does, is it teaches you to distribute. So here's how I teach foiling whenever I used to teach, or how I teach distributing. Do it never more than 2 polynomials at a time. If there was something else over here, ignore it for right now. We'll get to it in the end, okay? But for right now, here's what I'm going to do. I start with the very first term. Now, when you multiply terms, remember, multiplying terms, if you need to write this down somewhere, you multiply coefficients and you add exponents. So I start with the first term in the first parentheses, and I distribute it to everything in the second parentheses. So W times W squared gives you what? W to the third. That's exactly right. W times 2W. 2W squared. Remember, multiply the numbers in front, add the exponents. W times 1. All right, I'm done with that one. It has distributed through to everything now. I'm done. Now move on to the next term, -7. Distribute that to everything. What do you get? Oh, you're right, sorry. Thank you. Minus 7W squared. Yes? On to the next. Negative 14W. -7. Now we're back to like terms. Combine like terms. If you've done it in standard, if both of them were in standard form to start with, your life's a little easier. It's a little bit easier to find your like terms. But I've got a W to the third. Now look, 2W squared and negative 7W squared give me what? Negative 5W squared. I always cross mine out here to make sure I haven't missed one. W minus 14W, negative 13W. And then my little constant that sits out on the end. Classify that polynomial. It's a cubic polynomial. That's exactly right. It is a cubic polynomial. I'm not, unless y'all need me to do another example. I think y'all know how to do this. But do let me just say this. We still got to divide. Easy divide, though. We won't get to the, we'll spend 2 days on the real division, but today. What happens if I have something like this? Can I distribute that 3 inside? The only time you can distribute an exponent inside a parenthesis if you are multiplying or dividing. Remember how we put that in our exponent rules? If you ever add or subtract, it does not distribute. Instead, exponents tell you how many times to multiply it, right? I was waiting on somebody to go, oh. You never, never, never can do that. If you are adding or subtracting inside the parentheses, it does not work. That only works when you're multiplying the parentheses. Remember your exponent properties? It was power of a product or power of a quotient. It's never power of a sum. Which means I'd have to multiply these two together, get an answer, and then multiply it to that one. Yep. That's fun. No shortcut to that, no. I know that this is a lot today, and I still got to show you dividing, but a lot of it is, I wanted to spend some time reviewing them because I never know what y'all learned and what you didn't and what you remember and what you don't. So I'm going to assume that you added and subtracted prior to this. I'm going to assume you multiplied 2. Okay. Okay, well, what we're going to do today, I just want you to start getting familiar with division. Today, we're just going to look at division by a monomial instead of by anything else. Okay, So we're looking at polynomial over monomial. Now, before I do this, here's the concept behind this. If I have 5x plus 2 over, I don't know, 20. Do you understand that what this means, if I go backwards on adding and subtracting fractions, I could rewrite this as 5x over 20 plus 2 over 20. Do you agree with that? Right? Because if this was the problem you were given initially, you'd say, oh, well, if they have common denominators, I just combine the tops and over the same bottom, right? And you'd get this. But the concept behind division, since division is kind of the backwards here, I'm going to do this way. I'm going to take these fractions this way. So that's where you're going to, whenever you're adding or subtracting up top, and you just have one thing in the bottom, because I'm dividing by a monomial. So just one thing in the bottom. That's why this works, okay? So this is what we're going to do. We're going to take this polynomial. I think it's easier just to show you with an example. Let me get a good one. 30x cubed minus 12x squared plus 9x over 3x squared. I'm going to write as separate fractions and simplify each fraction. You'll see once you get it split into write as separate fractions and then simplify each one. Once you get them broken, these separate fractions like that, you're going to see it looks a lot like what you did with properties of x times. And that's why we're throwing this in here with today, because it really helps you with that. All right. Again, just like this 5x plus 2 over 20, and we split it up this way, tell me how you think you'd split that one up. Each of them goes over 3x squared, right? So I've got 30x cubed over 3x squared. Now look at the sign this here. Minus 12x squared over 3x squared. That's right. Plus 9x over 3x squared. Now that I've got them as three separate fractions, I can just simplify each fraction on its own. Okay? Now, this only works when it's a monomial in the bottom. There's no addition or subtraction in the bottom. It's just one little old thing. Okay? 30 divided by 3, 10. 3 minus 2, x is 1x. You try to simplify the second fraction, tell me what you, or don't blurt it out just yet, but simplify it and see what you get. What'd you get for the second one? It's just 4. 2 minus 2 is 0, x to the 0 is just 1, right? How about that last one? 3 over x. Division by a monomial. You subtract them, 3 minus 2. It's just 1, yeah. Tell me how you feel. Addition, subtraction, multiplication, and division by a monomial only. Everybody okay? That's just your answer.
Oh, oh.
All right.